In this video, we're going to learn about the p-value, but I want to first start by recapping what we saw in the last video. So here we've got a test about, let's see, a real estate agent believes that the average closing cost, so this is a z-test of the mean. I know it is a test of the mean because we're comparing averages. It's a z-test because my sample size is large enough, it's 40. If it were less than 30, I would need to also have a population standard deviation. So that makes this a z-test of the mean. We came up with the hypotheses. The null hypothesis always has the equal sign in it. The alternative hypothesis has one of the three inequalities, the not equals, less than, or greater than. Because this was not equals, it was a two-tail test, which means it could be either less than, so I'm pointing to the normal curve now, either less than or greater than. We used table F to find the critical value. Because it was a two-tail test and we had both tails, the critical z-score cut off the lower tail with a negative 1.96, and the positive z-score cut off the upper tail with a positive 1.96. These were the z-scores that cut off the rejection region. So when we use the calculator to compute the test value, here's our sample mean of 6572. It's definitely different than 6500, but we wanted to know if it was significantly so. The calculator gave us a test value of 1.347. That's the z-score that goes along with 6.572, which was not big enough to get up to that z-score in the rejection region. So that means, let's see, here's our decision. Our decision was fail, let's see, where is it? Fail to reject. And our conclusion just answered the question. She seemed to be correct. The average closing costs are $6,500. Now the reason that I recapped this was a couple of things. First of all, I want to recap those 5 steps. Hypothesis, critical value, which we get from table F, test value, we got that from the calculator, that's the z-score for our sample mean, our decision, that's where we landed on the normal curve, there it is, either fail to reject in the middle or reject because we're significantly different on the ends, and then our conclusion is summarizing what that means, really answering the question now. Well, we did a z-test of the mean, and we did a traditional method. And the traditional method happened in steps 2 and 3. In steps 2 and 3, we found the critical value, which was a z-score that cut off the rejection regions. And then we found the test value, which was also a z-score, but that was a z-score for the sample mean. So in the traditional method, you compare z-scores to figure out if you're in the rejection region or not. Well, the next method that we're going to look at will give us the same conclusion for this problem, but we're going to use the p-value method. I'm actually going to redo this problem using the p-value method. So you'll see differences in steps 2 and 3. Your hypotheses will be the same. Your decision and conclusion will be the same. So now let's take a look, not using the traditional method, but let's take a look at this question using the p-value method. This is still a z-test of the mean. So now using a p-value method. Let me first start by saying what the p-value is. So the p-value is equal to the size of the tail cut off by the sample. In this case, it's a sample mean. It could be a sample percentage or proportion. So the p-value is the size of the tail cut off by the sample mean. So in this case, we had, let's see, 6,500. That's supposed to be right in the middle. So 6,500 in the middle. Over here, we had 6,572. And when we look at a p-value method, we don't use z-scores at all. Instead, the question is, what is the size? What is the size? We know that our significance level for this test is 0.05. So the size has to be 0.05 or smaller to fit into the rejection region. So if the p-value fits the size, that p-value, so the size or the p-value fits inside the rejection region, then we reject. So in other words, the p-value would need to be smaller than alpha. Well, I really like this notion of fitting inside. We're not doing z-scores, so we're not looking at just a cutoff number on the normal curve. Instead, we're looking at an area. So when I say what's the size, I'm really saying what is the area of the region. It's got to be 0.05 or smaller if it's going to fit into the rejection region. Okay, so if you can remember that the p-value is equal to the size or the area, you are pretty much there. Okay, so now let's go ahead and apply the p-value to our test. I'm going to redo the test because it's great review. Let's go ahead and start by, we'll state our hypotheses. We know that we're looking for a null and an alternative hypothesis. So I'm going to cover up what we've done here. Feel free to pause and rewind if you need to. So we need step number 1, the hypotheses. So our hypotheses, we have a null hypothesis and an alternative hypothesis. The average closing cost is 6,500. That is a null hypothesis. The equals is always in the null hypothesis. Now we look for a statement of the alternative hypothesis. She selects 40 home sales, find the average cost is 6,572 with a standard deviation, test her belief. So nowhere does it say that she thinks it's greater than or less than. So that means she thinks it either is, or maybe we can prove that it isn't and that it's significantly different. These are the same hypotheses that we had when we did it with the traditional method. Step number 2, find the p-value. We're going to use the calculator, which barely fit, which we like to do. So we're going to use the calculator. I'm going to redraw that picture. The mean from the null hypothesis is always right in the middle. So this is 6,500. 6,572, I don't know how far away it is, but I'll just make something up. What I want to do is to figure out what the size of my rejection region. So this is the p-value, which equals the area of the tail cut off by our sample mean. Well, we can find that, right? We could find the z-score, and then from the z-score, we could use, what was it, inverse norm on the calculator's distribution menu. We could figure that out because we've gone through Chapter 6. But there's a much, much simpler way. Let's go ahead and just do a z-test of the mean. So we're going to do a z-test of the mean. I just grabbed one of my 2 calculators here. So it might look like yours. It might look a tiny bit different. You just need to pay attention. I go to Stat and then Tests. I'm doing just a z-test of the mean, so I start with that first one. I don't have data. I have computed statistics, averages that are already done for me. So I go ahead and move over to Stats and hit Enter. My hypothesized mean is 6,500. Standard deviation is 338. And my sample mean was 6,572. I had 40 in the sample, and it was a 2-tail test. So that not equals means a 2-tail test, and I'll calculate that. And we end up with a z-score of 1.347. We had that before, but I'm not interested in the z-score. I'm interested in the p-value. The p-value is 0.1779. So that means that this area right here in yellow, so this area right here is 0.1779. So this is an area of the tail. Step number 3. Compare to alpha. Alpha, let's go back to the statement of the problem. Alpha was 0.05. So alpha, my significance level, was 0.05. This is the area of the rejection region. So if I compare these two, the area of my rejection region is 0.05. I'm going to do that in orange. So here's the area of my tail, 0.05. But my p-value is much larger. It's 0.1779. So if I were to take this tail and fill it in here, I would have to fill in 17% of the area. So my p-value spills outside of that rejection tail. Whenever we're doing a p-value or an alpha, we're always filling in from the tail, from the end of the normal curve, even though it never ends. So from the end towards the middle. So my p-value here spills out of the rejection region. Spills out of rejection region. It doesn't fit. My rejection region also goes on forever here, but my rejection region is just what's in orange, 0.05. My p-value is what is in yellow. So we say that the p-value, this time it's too big. It's bigger than my alpha, 0.1779. The area cut off by my sample mean, which is here, is bigger than my alpha, my significance level, which was 0.05. Well, because I spilled out of the rejection region, that means that I'm in the fail to reject region. So step number 4, I'm in the fail to reject region, so I fail to reject. And then the last question is, let's see, what does it say? I need my conclusion still. Let's see, 1, 2, 3, 4, I'm on number 5. So number 5 is my conclusion. It says test her belief. Well, is her belief correct? She believes that the average closing cost is $6,500. We found that, here's my average closing cost right here, $6,572. It's bigger than $6,500, but not significantly bigger. I need to be in my orange rejection region to be significantly bigger. So my last step, number 5, my conclusion, I say her belief is correct. I can say the closing cost or closing costs are about $6,500. So the only thing I did different, I mean, $6,500 still lives in the same spot. $6,572 still lives in the same spot. I just didn't find z-scores. I didn't find the z-score that cut off the rejection region, and I didn't find a z-score for my sample mean. I just decided if the tail was small enough to fit in the rejection region or if it was too big and it spilled into the fail to reject region. Using the p-value method is very, very easy with a calculator. We'll do another one with the p-value method. I've got many, many students that just prefer the p-value method because of how easy it is to do with the calculator. So let's do a second one. What else do I have here? Oh, I've got a t-test of the mean. Let's do a p-value with a t-test of the mean. I don't use tables on these or formulas. I just use the calculator. It's just too easy. What I'm testing you on is that you can use the calculator, but really that you can lay out your steps, detail the important information, and then most importantly state your conclusion. Okay, so here's a t-test. A travel agent, this is from the previous video, a travel agent claims that the average of the number of rooms in hotels is 500. We have a significance level of 0.01. Is the claim realistic? This was a t-test because of a couple of things. We were given data. We have 1, 2, 3, 4, 5, 6, 7 data values, which is smaller than 30. So we have n less than 30. And we can come up with a sample standard deviation, but nowhere in the statement did it give me a population standard deviation. If I had the population standard deviation sigma, that would be enough information to define a normal curve and z-scores. But because of these two things, I used a t-test instead of a z-test. But I've got the same 5 steps because it's a traditional method. I've got my statement of the hypotheses, my critical value, which is a t in this case. The critical t's cut off the tails, my rejection region. Then I computed a test value, and that's for my sample mean. So this is the t value for the sample mean. I ended up failing to reject, and then I answered the question. It asked if the claim was realistic, and I said, yes, it is realistic. So let's go ahead and do the same tests now using the p-value method. This was traditional that we did. Now let's do the p-value method. So p-value. I'm not going to compute t-scores in this case, although I'm still going to ask my calculator for a t-test. Step number 1, hypotheses. The agent claims that the average is 500. Well, there's my null hypothesis. The average, you always use mu here. You don't use x bar or m. The average is 500. Now I'm looking for something that says less than or greater than. It just says, is it realistic? Which means, is it or isn't it? So not equal to 500. So there's step number 1. Step number 2, I need to find the p-value. So find the p-value, and we're going to do that using the calculator. So in order to do this with my calculator, I'm going to use my other calculator this time, but again, it will look very similar. You just need to pay attention. I'm going to type my data in. So I go to Stat, and then, edit. I'm going to clear what I've got in L1, clear, and then enter, and then I'll enter my data, 713, 300, 292, 311, 598, 401, and 618. I'm going to quit. I'm going to go to Stat, Tests. I'm on the T curve, so I still pick a t-test. T-test. I'm using data. I don't have computed statistics, so I move over to data and hit enter. The hypothesized mean, that's my 500. My data is an L1, so I can leave that. The frequencies, I'm not using a frequency list, so I leave this at 1. And I do have a two-tailed test with a not equal sign, and then I hit calculate. So it gives me the critical t-score, but I am interested in this p-value. So let me write that down. 0.5888. Okay, so the p-value is 0.5888. Okay, step number 3, compare. Compare the p-value with alpha. Okay, let's draw our picture. So this is my t curve. My hypothesized average number of rooms was 500. That's mu. And my calculator gave me the average number of rooms at 461.8. That's over here somewhere. 461.8. That's x bar. My p-value is the area cut off by my sample mean. So my yellow area is my p-value, and that's 0.5888. So that's a large p-value. So if I, let's see, so if I continue here, I want to compare my p-value with alpha. Alpha is 0.01, and we know that 0.01 is smaller than 0.5888. And actually, look what it gave me. Let me show you. It gave me this. See this area I drew right here? That's not 0.5888. 0.5 is the halfway mark. Well, it gave me a tail, and it gave me this tail. It gave me the right tail. Well, this is a two-tailed test, so it doesn't matter. That 0.01, let me show you, 0.01 is going to be split into two rejection regions. So 0.01 divided by 2. So divided by 2, that means we have 0.005. That's going to be over here and way over here. So isn't that funny? It actually gave me this larger value, but either way, I'm way too big, right? I was a two-tailed test. I need to fit into one of these tails. I don't fit into either of those tails. So I can still say, because my p-value is, let's see, my p-value, let me write it this way, my p-value is bigger than my alpha, so 0.5888. That does not fit into my significance level of 0.01. Since it doesn't fit, my p-value is too big for the rejection region. Therefore, step number 4, we fail to reject. And then step number 5, my conclusion, is the claim realistic? Yeah, we failed to reject. We'd have to reject for a significant difference. We did not find it. So yes, claim is realistic. So with that p-value method, you really just want to compare. This is the most important step here. Is your p-value smaller than alpha? If it is, it fits into the rejection region. Or is your p-value bigger than alpha? If it doesn't, if it isn't smaller and it's bigger than alpha, that means it spills into the fail to reject region like we did here and in the last example. We have just one more topic in this chapter, and that's the test of the proportion. This chapter has a pretty big learning curve, but once you've got it, it's really easy to move to a new test, and this is an example of that. So we're going to test proportions instead of means this time, but I'm going to use the same 5 steps. Instead of testing with a mu, we're going to test with a p. That's going to be our population proportion. And then p hat is going to be our sample proportion. Okay, so it's a little bit of notation there. So let's go ahead and read this one. So the largest group of moviegoers by age is the 40 to 59-year-old age group. This constitutes 32% of the population. A theater randomly surveyed customers over 3 weeks and found that out of 423 surveyed, 170 were between 40 and 59 years of age. At the 0.01 significance level, does this differ than the stated proportion? Another two-tailed test. I can tell because of that word differ. Okay, let's jot some things down. Alpha is 0.01. I said two-tailed test, so I'm just going to mark that down while I'm thinking about it. 423 were surveyed, so n is equal to 423. This 170 were in the age group. We call that x. So x is 170. When we put these two things together, p bar is x divided by n, 170 divided by 423. And when you run your test on the calculator, you'll see your calculator does most of this work for you, which is great, but I'll put it here just so you can get an idea. 170 divided by 423 is about 0.402, so it's about 40.2%, which seems bigger than the 32%. Okay, we need some hypotheses. So step number 1, hypotheses. Null hypothesis. Well, let's see. We didn't say we think it's more than or less than. We just wanted to know if it differed. So my proportion is either equal to 0.32 or it's not equal to 0.32. This is a two-tailed test, a two-tailed test. Okay, step number 2. Let's do this one with a traditional method, so I'm going to be looking for some z-scores. So let's go ahead and start by finding the critical z-scores. I'm going to use table F. Let me mark that this is traditional. and then we'll redo it, just the end of it anyway, with p-values at the end. So I need table F, and I'm looking at a two-tailed test with alpha equal to 0.01. So here's my table F. Table F, 0.01, two-tailed test. I go all the way to the bottom, and I find that I've got a z-score. So a z-score of 2.576. So 2.576 is what I'm looking for. So my critical z-scores, so z is plus and minus 2.576. Remember, this is a two-tail test. I have a region there and a rejection region here. So I need two cutoff scores. One is negative and one is positive. There's my z-scores. Okay, step number 3 is the test value, which is the z-score for my sample proportion. I could have just written p hat, right? It's for my sample p. So for my sample p hat. I use the calculator for this. This is one of the calculators, and I'll show you both. Again, they're slightly different, but if you're paying attention, you'll be fine. I go to stat and then tests. Now I go down here to 5 and 6. I've got a 1 proportion z-test or a 2 proportion z-test. There are no proportion t tests. You don't need to worry about sample size. So I'm doing a 1 proportion z-test. And it's going to ask me for the proportion in the hypothesis. It's very important that you're using p's instead of mu's, and that's 0.32. X is the number of 40 to 59-year-olds, and that's 170. And that was out of n, which is 423. And we are doing a two-tailed test with that not equals. So I choose not equals, and I hit calculate. We're doing a traditional method, so I want the first value, which is my z-score. That z-score, that critical z is, or the test value z is 3.61. So the z-score for my sample proportion is 3.61. Okay, 3.61, where does that live? 3.61, that lives way over here, well inside my rejection region. Now remember, what we're really doing is we're lining up our proportions. So this was my 32%, so this is 0.32 at 0, and 3.61 was at 0.402. That's my sample p. So remember, the z-scores that we're finding line up with the sample proportion and the stated proportion, that 0.32. Well, we're well into the rejection region, so our decision number 4 is to reject the null hypothesis. We found a significant difference. And then step number 5, we answer the question, does this differ from the stated proportion? And we say we found a significant, I'm going to just abbreviate, difference from the stated proportion. You should not abbreviate on your exam from the stated proportion. So see what I mean by switching gears? Here's a different kind of test. We tested proportions or percentages instead of means, but the skeleton was exactly the same. We had our same 5 steps. We used the calculator to come up with our test value, table F to come up with the critical values, and then we stated our hypotheses to begin with. Very, very similar. I'm going to go ahead and redo just part of this with the p-value method. I can start at number 2. So now let's continue with the p-value. So step number 2 is going to be to find the p-value. Well, guess what I already did? When I did my 1 proportion z-test with the calculator, it let me do either method. And it gave me the critical z, or the test z, I should say, and it also gave me this p-value. This E-4 is scientific notation. This is not valid notation for you to write down. Instead, you need to interpret what the calculator means. This means 3.0, I'm going to round that to 6, times 10 to the negative 4. So you interpret that e, when you write it down, as times 10 to the negative 4. I will not count it if you're just copying and not understanding what that means. 10 to the negative 4, that means we've got 4 decimal places before we hit this decimal place. So 1, 2, 3, 4, 0, 6. Did you see how I did that? 1, 2, 3, 4. So I count 1, 2, 3, 4 decimal places. That's where it was between the 3 and the 0. This is tiny, right? A tiny, remember this is an area. A really, really tiny area. So when we get to step number 3 and we compare to alpha, which is 0.01, okay, 0.01. I think I was making my rejection region orange, wasn't I? So let's put 0.01. Let's see, that was a two-tailed test, so split between 2 regions. 0.01 is here and here. You can split this between 2 regions, whatever you want to do. Even if you split this in 2, it's tiny. It's way over here and way over here. It's too tiny. This p-value is smaller than my significance value. Remember, these are sizes. So the size cut off by my sample proportion is smaller than the size of the rejection region. So that means it fits into the rejection region. It's tiny. Of course it fits into my rejection region. And we can say step number 4, we reject the null hypothesis. And then step number 5, this should all be the same from the last one. We did find a significant difference. Yes, there is a ... because it's the same as the last time. So that's how you do a test of proportions. It's very easy once you've got that same 5-step process, and you can do it either using the traditional method, which we did first, or you can use the p-value method, which is how we finished.